Oh, good morning. Let's get started. Welcome to our review meeting. Today we look at the 1.112 release, and we have 5 topics. We will start with Dominic, with a topic from actually last release, which we moved to today's session about prevent leaking the service IP of the kube-apiserver. Then I will give a short demo about the credentials rotation feature without triggering the worker node rollout. Then we have Oliver with a change in the operating system config library and a wrapper that we introduced for the provisioning script. Mark will show PR for configuring the priorities for worker pools to make cluster autoscaler work properly. And finally, Peter with using structured authentication with the Gardener dashboard.
Test. Okay.
Then
Sorry.
Please get started, Dominic.
Okay. All right. Thank you. Let me just start the share. All right, then. Hope you can see my screen. I got a couple slides just from making this easier to understand. Okay, so the kube-apiserver IP mapping, what's this all about? So first of all, what are we doing now? As you may know, the seed and shoot have some limitations regarding the network ranges, so you cannot have overlapping IP ranges with your seed. And we are working on removing that restriction. And one puzzle piece of that is the apiserver proxy, which has an IP address currently that's actually from the seed. It's the service IP of the kube-apiserver service on the seed, and we want to get rid of that so that you may use that IP in the shoot later on. We opted to use a restricted range that you cannot use for other IP address ranges. It's the 240/4 range. It was going to be used by a Class E network, which never came to pass, but it's still restricted. And we figured it's relatively safe to move our nutting shenanigans into that range and leave all of the lower ranges up for the shoot. So this only applies to IPv4 shoots, by the way. So if you have a IPv6 shoot, that doesn't apply to you anyways, and you shouldn't have any real clash issues with the seed. And the changes are very small for now because this is only one first step. So on the seed side, nothing changes. It's very easy. On the shoot side, you have this Kubernetes service, which currently has an endpoint that points to the service IP of the kube-apiserver on the seed. And we changed that one IP to a different range. So we map it to the 240/8 CIDR range. So if you take a look at your service in your shoot, and for example, if you had this 10.123 IP there, this IP will change to 240. So the first byte will change to 240. That's not a real big problem because that IP is never used outside the shoot. It only exists on your local loopback device, on your nodes. And this means that this old IP disappears from your shoot, and you can later on, once you have you have the full separation between seed and shoot, you can reuse that IP on your local shoot. The limitation of that, for now, the seed and shoot ranges must still be disjunct, so you cannot, as of yet, use the same ranges, but this will come later on. Obviously, if we are going to map this IP address to a /8 range, you cannot use anything larger than a /8 for your local networks, for your shoot. And you cannot use, obviously, the 240 range yourself for your networks. So why are we all doing this? The end goal is to have something like this. So you have the seed side, you have the shoot side. They both have the same ranges, and you could technically have a pod service or node using the exact same IP address as on the seed. So we want to make this work. And obviously, we need to do some little magic to avoid clashes here. As you may know, we have VPN in between. That's the main reason we cannot do this right now. We have to do a little nutting and unnutting and mapping and other stuff to make this work. Okay, so this works basically when your pod goes out and calls the Kubernetes service. This translates to a cluster IP, which has an endpoint that previously was this IP on the seed side. And this IP is now changed to this 240 range, which is locally mounted to your local loopback device. And that's the end of it. So there's an envoy running. This envoy basically takes your request and proxies that request back to the seed where it's connected to the Istio gateway, and Istio will make sure that it reaches your API server. I have a little demo. It's very, very small. I hope you can see my terminal. On the left side, you can see the cluster IP of my kube-apiserver server in the seed. And on the left side, we have the endpoints of the Kubernetes server in the chute. And you can see they are basically the same IP address, except that the first octet was changed to 240. And that's the only change we did for now. So you don't need to worry about if that IP address is actually used anywhere. As a matter of fact, I could show you it's just used here on my local node. Let's do a little node shell there and take a look. So I have this local loopback device here, and this is where this IP reappears. And this is actually the IP address that's bound to the envoy process running on your local node. And it never leaves that node. So I think that's it. If you have any questions, just raise them now. Otherwise, I'm done. Yeah.
Thanks for the change. I'm wondering why the IP still needs to be chute specific. So right, we're taking the cluster IP of the kube-apiserver service, as you said, and transforming the first byte. Would it be possible to take just one IP out of this unusable range that is the same for all chute clusters? That's my question.
So in the previous implementation with proxy protocol, that's not possible because you would need one IP address. You would need to distinguish at the Istio gateway from which chute cluster it actually came.
So the IP is used in the ingress gateway.
It's used for the destination.
Exactly.
Distinguishing. Okay. But
I mean, with the
with
HTTP
the latest
connect,
change,
it can change again. Yes.
Okay, got it. Thanks.
All right. Thank you.
Thanks, Dominic. Then let's continue with the second topic. Second topic is presented by me. It's about this PR triggering nodes rollout individually per worker pool during credentials rotation. If you remember, we have already presented this some weeks back because it was a result of the last Gartner hackathon. So this is actually this topic here. And yeah, now it has been finally implemented and also merged and released. So I want to raise some attention again and awareness about this feature. So what is it about? Basically, it's covering or addressing this issue here. And the problem statement that is basically described here is that some chute owners might need to have more control of when individual worker groups are rolled. And previously, before this PR, when you triggered a credentials rotation, we always started a rollout of all worker pools, all the nodes in the shoot cluster at the same time, more or less. And this doesn't work well for some use cases where people want to do this individually, basically. So that was the motivation to introduce this feature. Going to the documentation for credentials rotation, there's the section for certificate authority rotation and also for service account signing key, which now have a subsection triggering worker node rollout individually. It's basically works similar for both credential types. So what we have done is introduced a new operation annotation at the shoot, rotate CA start, and then there is this suffix without workers rollout. Or there's also rotate credentials start, which basically triggers all the credentials rollout at the same time. And yeah, this basically creates new credentials, but does not yet trigger a rollout of the worker pools. This is then something that the stakeholder can do individually by using this operation annotation, which is called rotate rollout workers. And then you can have basically a list of pool names that you want to now roll out. And this allows you to do this one by one or whatever subsets you want to roll. But now you have all the control about it. And only when all the pools have been rolled out, then you can perform the second step of the credentials rotation, which is completing it, meaning that the old credentials are invalidated. Okay, that's all about it. I will show a demo in a minute. Just to mention, this feature is currently backed behind a feature gate because we have changed some logic in the extensions library, and all the provider extensions have to basically re-render the relevant Gartner version or a newer one before the feature works. So that's why we decided to introduce this feature gate, which can only be enabled if the installed provider extensions have been updated accordingly. Okay, let's jump to the demo. I already pre-created a shoot and triggered some rotations. So let's take a look in the shoot status. There is this credentials rotation section as before. And then we have some data for the individual credential types. And what I have done just before this meeting was to start the credentials rotation without the workers rollout. So I basically used this annotation that I explained before, and with this caused the creation of new credentials. So how does the shoot status look like now? Some of them are in phase prepared. Those are the credentials that do not cause a rolling update of the worker nodes. So etcd encryption key is one example. But for certificate authorities and for service account key, the phase is currently waiting for workers rollout. So previously this was then the prepared phase, but now we have this intermediate phase. And we also have a new list of pools that are pending for the rollout. So the pool names here, local and local 2, basically reflect my specification. So I have 2 worker pools. One is called local and the other one is called local 2. And those are now the 2 that are also pending for rollout. So as explained in the documentation, what I now can do is use this rotate rollout workers annotation. I could now decide to first start the rollout of local only or local 2, whatever, or I can do both at the same time, whatever suits my needs and use cases. And this now will, as before, finally cause the rotation of the nodes. So this now takes a while. until this is finished. But what we already see in the status credentials rotation section is that there are no pending worker pools anymore because I just triggered them. So this means once this suit reconciliation finishes, this phase here waiting for workers rollout will transition to prepared as well. And with this, all the phases are then in prepared, which allows to complete the rotation. Okay, yeah, as said, this takes a couple of minutes, so I would suggest to stop here. Then you have seen the gist of the feature. And yeah, as said, this will be back behind the feature gate, so make sure that the provider extensions are re-rendered before you enable it. All right, any questions to that?
A quick question. You showed that you can annotate the rollout of a certain worker pool. What would happen if someone would figure to, let's say, roll nodes individually on his own? Would that also work, or would it require the rollout of at least one pool?
You mean if the stakeholder just deletes the node objects and let the machine controller create new one?
Yes, exactly.
Yeah. Yeah, that will not remove the pools from the pending rollout list because what happens under the hood is that this machine or worker pool hash, as it's called, is recomputed, and one part of this computation is this last initiation time of when the credentials rollout has been triggered.
Mhm.
So even if the user manually already deletes all the nodes and recreates them, this computation still has to happen to reflect the proper timing here in the hash, in the resources in the feed, so machine class name and other things maybe. So yeah, that won't work, unfortunately. But what will work is that if a stakeholder decides to remove a worker pool because it's no longer needed or because they do blue-green updates from one worker pool to another one, then it disappears from the list. And because it's gone, obviously, and there's no need to roll anything.
Okay, thanks.
Okay, then thank you. And let's continue with our third topic for today. That's the operating system config provisioning script wrapper presented by Oliver.
Yeah. Good morning. Yeah, I'd like to present this small PR. It's about a, let's say, bug in the init version of this operating system config, or in the bash script, which is applying it. So we have these two operating system configs. One is the original, which is applied on every reconciliation, and one is this init operating system config, which is just for bootstrapping a node. And we already or we assumed that this init operating system config is just applied once during bootstrapping of a node. But it turned out in many providers we are using a user data script to run or to apply this operating system config, this initial one. And it turned out that for many providers, this user data script is not a kind of provisioning script, but it's a startup script. So it's running on each reboot of a virtual machine. And created an issue for this, and this this in the end we have some weird issues. We just found it out because we were rolling out the node agent with the feature gate. So what basically happened was we bootstrapped the node with this node agent authorizer feature gate false, and later on the node was the shoot was updated and this feature gate was turned to true. And afterwards, the node rebooted for some reason, and we found out an error during reconciliation, and apparently node agent wanted to roll back to the previous state with the feature gate turned off. And yeah, it took a while to figure it out. So as I said, this user data script is running on each reboot, but it's not running as the first script. So basically the issue turned out at the not at the reboot, but on the next restart of Gardener node agent after the reboot. Yeah, it's somehow described here. And the fix for this is here, this wrapper script in or in this PR. It's you see here, it's in the extensions library, and basically it wraps this user data script into a one-shot script that we exit early when it's already ran once. And this script needs to be added to the different OS extensions. We already did that for a couple of extensions, like here the Garden Linux one. So the change in the extension is rather small. So basically you just have to add this one line and at the right place, and then the script is wrapped. And this should fix the issue. So from that point on, the user data script should really be applied only once. We figured it out for the node agent, this issue. But when we looked at this scripts here in the OS extensions, there are some more things which should be applied only once. So there might be other issues, strange issues on the nodes when they're rebooting. We did not notice so far. That's basically it. When I checked the issue, I just saw that we did not create a PR for Core OS yet. I will do so after the meeting. Any questions? Yes, that's it.
Okay, thanks, Oliver. No questions. Then let's continue with Mark and the cluster autoscaler priority expander configuration.
Thanks, Raphael. As Raphael said, cluster autoscaler for the priority expander has been implemented by Tobias. He's currently on vacation. As you can see here with this change now, it's possible to specify the priorities of your worker groups directly in the shoot spec. To give you the motivation for this change, basically you can imagine that there are people that would like to configure this right when they create their shoot cluster, and not after you've created your shoot cluster and waited for the first node to come up to place your config map for the configuration. So now this is part of the template and directly activated while your shoot cluster is being created. Why is this necessary? So maybe you have a preference for the worker groups or worker group where your system components should run, or maybe you have known hyperscaler shortages for certain machines where you want your priority to take place and spin up the nodes faster. To give you a quick demo, let me first give you a quick overview. So at the top, I have the virtual garden with, and I'm logged out. I have the virtual garden with the shoots in my project. On the left-hand side here, I have an existing shoot with an existing cluster autoscaler priority expander configuration. And on the right side here, I have the control plane of my shoot with all of the available machines. Let me first give you the example of a shoot spec that I prepared, just to show you how that looks like. So in your workers configuration, you have the optional field priority, where you can configure a numeric priority. As I said, it's optional, so you can also not specify it. And if you specified it anywhere else, it will default to 0. So a lesser priority. And we can then apply this shoot spec. And then while the cluster is being created, automatically the config map is being generated based from this configuration and placed in the kube system namespace of your shoot cluster. While we wait for this to run, let's come back to the shoot cluster I already have. So let's say I have the legacy way of configuring this. I already have the config map here. As you can see, I have configured this for 2 worker groups. Let's take a quick look at how the shoot cluster is configured. So as you can see, it looks similar to the template I've just shown you. I have a worker group for cheap and slow machines. I have a worker group for my sweet spot machine and a worker group for very expensive but fast machines. So basically 3 worker groups. I already have the config map here, but now I want to make use of the new feature. So I will go back to my shoot here and I will start editing the configuration. And let's say that I'm interested that the cheap and slow group takes priority in all cases, since I don't want to spend that much money. And secondary, I'll give a priority of 20 to the sweet spot group and no priority for the expensive group. I have saved the shoot configuration. Now the reconciler is running, and once it picks up this configuration, this is very important to mention, it will override this config map that I've already created here, and it will turn into a managed resource that I then only will be able to edit based from my shoot template. So very important to note that if you have an existing configuration and you make use of this feature, your config map will suddenly be lost. While we wait for the reconciler to kick in, I will just simulate that my node is maybe at capacity now. So let's just disable scheduling, revisit the config map. Let's take this. It did not kick in yet, I think. Yeah, now it did. So you can see now it turned into a managed resource, or it's controlled by a managed resource, let's say it like that. And based on the priority configuration I've given in the shoot spec, it automatically puts all the necessary entries into the config map. So you can see what we did before. The cheap and slow group has the highest priority, sweet spot in the middle, and expensive and fast gets no priority. As I've disabled scheduling on the node, the only node I have, let's say I will now want to create a new deployment. I expect that this will not be able to start running right away since it can't find a node for the pods to run on. And then we want to see that it picks from the sweet spot worker group a machine, since the cheap and slow group is limited to 1 node maximum. So let's create a deployment. We can check what's going on with the deployment. So we see the pods are pending. And if we look in here, exactly what we expected. So currently it can't schedule them, but you can already see in the control plane that a machine of the sweet spot worker group is coming up and has been picked by the cluster autoscaler based on the priority to fulfill this. And that's basically it. Are there any questions?
Can you
specifying your microphone is very quiet, Marco. Maybe it bumps up automatically. Teams is stuff. Is it getting better? Yes, better. Okay, perfect. Yeah, so can you elaborate a bit how specifying those properties, those priorities in the shoot spec relates to what people might have been doing already, like specifying the config map and how to like transition maybe if they have already been doing this? Yeah, if you've already been doing this, right, you already have maybe a larger config map with all your configuration in. Transitioning should not be that difficult since you basically can take the priorities and directly put them in the, maybe let's jump back here, right? You can directly put them basically semantically where they fit best, right? So where you define your worker groups anyway, you put the priority next to it. If you've worked with regex or regular expressions before, then maybe that's a bit more work, but yeah, my expectation would be it should not be that difficult. So basically take the information you already have, work it into your shoot spec, and then you will automatically have this config map generated. And you can use it from the get-go when creating your shoot cluster. Okay, and essentially this means on shoot reconciliation, whatever changes I made to that config map manually will be overwritten by what's coming from the shoot spec, right? Correct. Yeah. Okay. So that's why I mentioned, right, that the config map is now controlled by a managed resource, so any change will be lost. Yeah, makes sense. Okay, thanks. Welcome.
Any other questions? If not, then over to Peter for the last topic for today, structured authentication with the Gartner dashboard.
Yes. So I'm presenting the pull request from Tim Usner, which basically makes it possible to configure structured authentication together with the Gartner dashboard ORDC configuration, where previously, if you configure structured authentication together with the dashboard ORDC configuration, it would result in a validation error. And for the demo, I have already prepared a Garden resource. In my Garden resource, I have set an ORDC config for the kube-apiserver as well as an ORDC config for the Gartner dashboard. Now, with Kubernetes versions 130 or higher, you can set the structured authentication, or you can enable this feature. And this is also the preferred way of doing the ORDC config. And when setting or enabling the structured authentication, the ORDC config must not be set anymore, and therefore I will remove it from my config and enable the structured authentication. Under structured authentication, you also have to reference the config map that holds the structured authentication configuration, which is basically the config map that you can see on the right side here. This holds basically the same configuration that we had previously under ORDC config, just in a different structure. And yeah, let's save that. And now let's see what happens if we apply these values or these resources to a cluster where an old operator runs. I already did that here. I had an operator running in version below 1.1.1. And when applying the this file, it will result in a validation error saying that the ORDC config of the kube-apiserver must be set when configuring the ORDC config for the dashboard. But you cannot set the ORDC config when you have structured authentication enabled. So this is what Tim has fixed. And let's see what happens when we apply the resource to a cluster with a fixed operator version. Here I have 1.1.1.12 deployed, and we apply this resource, but still it doesn't work. because you now have to specify 2 additional fields, the issuer URL and a public client ID. So previously with the OIDC config, the operator would take the issuer URL and the client ID and use that, or use these values for the dashboard OIDC configuration. Now with the structured authentication, of course, the operator could implicitly read like the first issuer and take that, and also read the first audience and take that as the public client ID. But instead of implicitly doing that, we said it's better to explicitly configure it on the dashboard so that it's clearer which values are used for what. Okay, so let's also set these 2 new fields and apply the resource again. This time it worked. And the reconcile starts and the API server is rolled. Also the dashboard will be rolled, and yeah, then it should work as before with the OIDC config, just with structured authentication. Yeah, this will take 1.5 minutes. Not sure if we need or want to wait for that. Yeah, but
Yeah, probably not.
yeah.
Go to the question section. Notice there was in the error message you showed, it was talking about Gartner dashboard.OIDC.
Yes. Oh, it was.
But it's actually called OIDC config, right?
Yes, yes. There's also already a pull request open that fixes this. Yes, it's
Okay.
it must be OIDC config. Like here. Yeah.
Okay. Other questions? If not, then thanks, Peter. And with this, we are at the end of today's session. Thanks everybody for joining, and thanks to our presenters. We'll meet again next week for the Gartner release that is about to be released end of this week then. Have a good time. Bye-bye.
Bye.
Thank you.
Bye.
Bye-bye.
Bye-bye.